Okay, so this one is under our module 7. We're going to look into a new, basically it's quite similar. Last time we learned MPI. But now it is still there. Got a MP, but now it's replaced with Open MP. So what is the difference between MPI and Open MP? If you look into Open MP, the meaning is it's going to be used in terms of the programming for Open MP when you have a programs mean as so means several program. You open your words, you open your Photoshop, you open your uh, YouTube, Google Chrome, you open several other program parallelly, and then you're going to execute it on a multi-processor system. This is when you need to apply OpenMP programming. So whenever you have a situation when you want uh, when you have several problem, which is they ask you to create a program that you can enable a parallel program to be executed, to be run parallelly, simultaneously, but in terms of a multiple processor system. So you're going to execute it using multi-processor. It is not a single processor, which is you open, let's say you open several program, but you need to like wait, or how you're going to justify your programming in terms of if let's say you are depending on single processor. So now in our OpenMP, it is a multiple processor. And normally it's quite different if you look into your MPI. You never find out about pragma. So now in OpenMP, which is directive in our C or C++, which is based on pragma compiler directive. So that's why you're going to have pragma normally, which is OpenMP directive format. So in terms of a command, is it a command, right? If you want to have a command for OpenMP, this is the standard. You're going to have some in terms of your pragma. Maybe what is the pragma that you need depending on your process, on your activities in your source code. And then you have a pragma list and space and clouds list. So let's take a look. Okay, okay, this is the example. If this is the standard for a structure block, basically it's similar. Pragma OMP pragmas, and then you have a clause. The program will execute serially until they encounter the parallel directive. So before you like give instruction, maybe you open your words, and also another one, maybe you open your PDF, Adobe, right? So this is two different program. So before you like giving any instruction or any trigger to both of this program, they're going to execute serially. In terms of course, you cannot see in your processor, right? So maybe you open this one first. So your processor will process this word program first, and then it's going to follow by PDF. This is means serial. So one by one. When you encounter, when you find or there is a trigger, or maybe you give instructions to use a parallel directive, then you're going to execute both application, your words and your PDF, parallelly. This directive is responsible for creating a group of trash. So you're going to open a trash, let's say trash A, trash B, or 1 and 2. So both, let's say over here, this one will be run under processor 1 and then processor 2. So what will be happen, and what program will be uh, running under your processor 1, and what is a process program under processor 2. So it's depend on how you're going to create the thread. Later on you will see also what is the thread, because this one is quite I don't think it's not it is new, but you need to create the threads first. The numbers of thread can be specified in the directive itself. You are the one, which is you as a programmer, will decide. You're going to decide how many thread that you need. So it's also depend on your question. So how many threads? Sometimes it's not going to give you like too direct. The number of thread is 7, let's say. Number of thread is 5. Or sometimes the question will be like a bit tricky. They're not going to mention directly that is the thread numbers. So you need to know also, and try to have a look into like several kind of questions, how they ask in term of maksud tersirat macam tu lah maksud tersirat. It is not direct question. So set using environments variables or runtime using your MPI functions. Each thread created by this directive executes the structure block specified by the parallel directive. So you're going to see over here, we're going to see about 5 libraries. Open MP libraries function. There are 5. First is set num threads, and then you're going to see it's called, sometimes it's called look like similar. You can see over here, this name is totally similar. Only then the different quite similar. You can see sometimes it's only different on set. Get is also similar, but the different on num and maximum and so on. So you need to know all of the MPI library functions. There are 5 altogether over here in our notes, which is set num threads, int num threads. What is the functions of this library is set the default number of thread that will be created on encountering the next parallel directive. So you can see over here, set the default number of thread that will created on encountering the next parallel directive. And then second is get num thread, which is the function is to return the number of thread participating in a themes. Third is your get maximum thread, which is return the maximum number of threads that could possibly be created by parallel directive encounter which does not have a num cluster. And also there is another two, which is your get thread num. And lastly, your om, get, nam, pros. So under your om, get, treat, nums, it is the function for you to return a unique treat number for each treat in a team. The numbers written lies between 0, which is called as a master traits, and also om, get, num traits, which is a -1. Om, get, num pros is a last OpenMP library function, which is written the number of processes that are available to execute the threaded program. Okay, now over here, similar to your different kind of programming that available, same goes to OpenMP. We have some functions in our OpenMP we call as a pragma. So what a pragma that available under OpenMP is parallel for, section, parallel section, critical, single in the pragma. So you can find all the description, what is the functions of all the pragma listed in this table. So all of these are under OpenMP pragma. Basically, there is others also, but this is the most useful uh, regularly that is going to be used in your OpenMP. So maybe you can take a look also one by one in our parallel for our pragma parallel, which is the function should precedes a block of codes to be executed in parallel by multiple threads. And for for, it is a for loop, which independent iterations that may be divided among multi-threads. For parallel for, you can see sometimes it's going to be quite similar. Same also with your C and C++ programming. This one is parallel, this one also parallel, but this is having a parallel for, means that is a combinations of parallel and also your for, which is also including the loops. And you have a sections, and then you also have the combinations of parallel and section, and lastly the critical or maybe only single. So you need to know how to specify a concurrent task. Let's say you were given the task, right? So how are you going to specify that concurrent task? The for, which is stated over here, the for directive under your pragma for as given. Let's say you were given the example, okay, your pragma over here, you need to have pragma in front or the beginning of the sentence for the standard. So you can see over here, this is the standard open MP directive format. So you're going to have pragma and what pragma functions that you're going to use. And then you have a clause list. So same also over here. You can see pragma So your directive is a for your pragma. And your clause list not yet mentioned over here. But you can see you already have the for directive, which is you put and apply it into your format here, which is your pragma list. And another one, later on we're going to learn on the clause list, but now we focus on our pragma list, which is we have parallel 4, parallel 4, section, parallel section, critical or single. So you can see over here, pragma on 4. So what is the function? It is a for loop, which is independent iterations that may be divided among a multi-threads. And you can see over here, the directive is used to split for loop iteration across a thread. The clause that can be used in this context is private. So this is the cloud list that can be used for directive. Private, first private, last private, if, reduction, schedule, no wait, and lastly order. So now you can see there are several cloud lists that you can use. Okay, this one is example pragma 4 for you to be used. Kejap ya, saya cari charger. Bateri nak habis. Okay. Okay, this one is example for you to use the command for pragma 4. So you can see over here, example pragma 4, sum equal to 0. Okay, you can see over here, you can see sum equal to 0 and equal to 3, which is pragma 4. For you have I equal to 0, I less than n, and I plus plus mean your I first will start with 0 value. And then you're going to have a loop, right? Basically, 4 will be having a looping if you have these specific cases or scenario. You can see over here. And then it's going to be like increase. Your I will be increased. I first will be 0. And then after that, it will increase to be 1. And you will check, is I is less than Y? Is less than N? Yes, right, because it's 1. Your N is 3. And then it will loop again. It's going to be I equal to 2. Is it still less than N? And if you loop another 4 times, you're going to be see that it's equal. So means it's not less than n, means that it's going to be stopped for your 4. If it's beyond from this scenario, so you're not going to be get the output like stated here, which is your output is your I equal to I multiple with I, which is, let's say, for your output case 1, let's say for I, and then you have equal to 0 multiple with 0. Of course, you're going to be get 0. If 1, then you will get 1 times 1, and etc. So this is how you're going to get the output depending on the scenario given. You're not going to give like mathematical terms of activities here, but in terms of looping, you can also get the functions quite similar to your mathematical equation. And that is under pragma. You can try also take a look others different kind of pragma. And now we're going to see the section directive. The four directive issues for partitioning. I guess I'm not going to read all of this. Okay. So we're going to see the example of the section directive. So let's say you have a scenario. You were given with three scenario, which is A, B, and also another one C. So all of these tasks need to be executed. So you need to have some assumption over here, which is you need to assume that these tasks, all of these tasks are independent of each other. If it dependent, let's say, I'll give you an example why it put independent, because normally going to be a parallel means you can execute A, B, and C because the output or maybe the input that you want to take to be used for A is not from B or not from C. Let's say I give you an example if it dependent. If it dependent, let's say B having a function of A plus whatever equation having. So means that you need to wait the answer for A first, which is it depend on your task A. So that's why in this question you were given the assumptions that A, B, C it is independent, means that there is no uh, tak ada kaitan, there is no correlation between each other, so they can execute by themselves, they can run it by themselves for each other and can be executed in parallel, they can be executed parallelly. OpenMP support non-interactive parallel task assignment using section directive. So OpenMP support non-iterative parallel task assignment using a section directive. So this is the functions of your section directive, which means that your task over here going to use the section directive for each of them. This section directive assign the structure block to each section to one thread. So for all of these, they have their own structures for each section them. So you're going to have to be one thread. So let's take a look at the example. For executing these three tasks A, B, and C concurrently, the responding section directive is follow. So you're going to have, you can see, you are using parallel section because you're going to combine parallel and section together. That's why you're going to use the parallel sections for your pragma om. Then this one is pragma om section because you are being asked to use the task for each of them using a section directive. So A have their own, B have their own, C have their own because it's blocked for each others. And that's why one is under A only. And then you have another pragma om section. you're going to be have for your task B, and another section for your task C. So you need to look into under section over here. It is a series of block codes. That's why it's going to be given over here block, but you need to have several. If it is only one task single, you can use a single also because it is single. It is a block, but it is for single thread. But if you have several, like this one, you have A, B, C. You're going to use a section, pragma section. Then you can combine have a several section together. And if you need to have merging directive, OpenMP allow the programmer to merge directive. The parallel directive can be merged with for and section directive respectively, which is you're going to perform your parallel for and parallel section. If you look into your pragma table, you're going to see you can combine several like parallel for and parallel section. There's others, there is no combination, isn't it? So you're going to combine these two only under a merging directive. So what is merging directive? It's going to allow you as a programmer to merge directive, whether it is for or parallel. So you can see you can only merge the parallel and for also a section. When you have a parallel for and parallel section respectively. Only two merging directives. So it's easy for you to memorize it. Next is, okay, this is the example on the merging directive. Over here, you can see you're going to use the parallel for. First, you can see you have the on parallel and you're going to have a share. How many and you can have over here? Sorry. So pragma 4 equal to, okay, this one is just a formal or simple scenario. Normally we're going to use like this if we want to increase. And then of course and value we're going to declare above. So is identicals to similar, which is parallel parallel 4. But you can see what is the difference. Over here, if you have parallel parallel and then you have share, you need to have another declarations on the parallel 4. Instead of you type parallel parallel share, and then you need to have another looping inside, you can just directly combine this parallel pragma 4 into your parallel. You can see over here before this, okay, like this, right? If you have pragma 4 over here, let's say the parents in before your looping for your looping 4, you're going to have like parallel. So you can just remove it and you combine these 4 into your parents like this. So you combine with your parallel uh, and it going to be like this. So basically it is similar. You can have parallel share and then you have another child pragma 4. But when you combine, you're going to see you have pragma on parallel 4 over here, and then share. And no need to declare another child's below these parents, parallel on parallel share. You're going to have directly to be a 4 scenario. So this is how you're going to use your merging directive. So you can have another one is section, parallel section. So this is another example in the parallel section. Same goes what we already see here. When we have several parallel section, you can see you have a parallel on parallel section, and then you have child 1, child 2, child 3. This one is the parent. So you can see you can combine all these sections together with your parallel. This is the example you can see over here. Your pragma on parallel. You have a section for section task A, task B, and how you're going to define it as merging directive. So you're going to put the sections over here. So that's why after this, you're going to combine this child together with your parents. Now you have your pragma om section, task A, task B, task C, and so on. That is on the merging directive. You have take a look into several example, and now you're going to look into synchronized structure in open MP barrier. So what is synchronized point under the barrier directive? So you can see the synchronized point, the directive barrier, the barrier directive general format is like this. Pragma on barrier. Last time, if you look into the format, go back to this slide. So you can see it's quite different, which is pragma on, but now it's going to be a what is it? Okay, now you're going to see it's going to be a barrier instead of your pragma. So over here, you can see on encountering this directive, all treat in a team waits until others have finished and caught up with the rest and the release. So instead of the sentences, maybe it's going to be quite confused. You're going to see when you're going to apply it later on. So now before we going to look into deeper on our pragma on barrier, under our barrier, we're going to look into the structures under our open MP, which is single and master. You have two type of your synchronized structures, which is single and master. You have a single thread education, which is the single and master directive. How and what is the general form for your open MP for synchronized structure? First is pragma om single clause list. which is a structure block. You can see over here, uh, upon entering a single block, the first thread enter the block, other threads skip the block. So when you have a single, which is under structure block, you're going to enter a single block. The first thread will be enter the block, and the others will skip. Uh, but for a master, which is under structure block, your master's directive is specific spe- specializations on the single directive, in which only the master thread execute the structure block. So only your master thread will be execute, but for single, whoever is the first thread is going to be enter the block first and execute. But under our master, it's going to be only the master thread that going to be execute. Next slide. Synchronize construct in OpenMP critical. So under critical section, you can see the critical directive. So sometimes rest condition occur among threads in accessing share variables. Or section. So therefore, it is necessary to have mechanism to control the access order or critically share variables or section by multiple threads. OpenMP provide a critical directive for implementing the critical region. When you have a critical where is it? Okay. When you have the critical directive, you can apply and implement any kind of critical regions onto your OpenMP. So this is under a critical structure. Instead of you have a single and master only, you can also have the construction under a critical directive. So the general format or standard when you want to apply the critical under your OpenMP and the critical directive, you're going to put a pragma on critical. So same goes what about your clause list. So this is the general standard and also format. Over here, you can see this is example when you want to apply your critical uh, your your critical directive into your OpenMP. So how about, let's say, you're going to consider a loop. So this is the code that were given pragma on parallel 4. Now you can see you have the merging. You have a merging over here which is parallel 4. You have a total equal to 0. Then you have 4x equal to 0 and then x be less than 2, x plus plus. So total will be your total plus 3. So you're going to calculate it until I guess it is 1, 2, 3. 3 times looping. So you need to assume that number of thread is 2. Which is you're going to have thread A or thread 1 and thread 2, or maybe you have a thread A and thread B. Thread A implement this one. Total equal to total 0 plus 3, which is equal of 3. In correct condition, before treat A, write the new total value which is your treat B implements, which is total equal to 0 plus 3 equal to 3. So this is the incorrect condition. Synchronized conditions are still under critical. So you're going to have, let's say this is the scenario given. So how you're going to give a corrections, which is solution, pragma on parallel equal to total equal to 0. For x equal to 0, x less than 2, x plus plus. So how you going to apply it under your critical? So you're going to put like this. So how about the different? There is no much difference between these two. How to delete? Okay, this one. This is the answer for you to apply the critical, which is you just need to uh, add on the pragma on critical, and same goes to here. So you just apply this solution into your pragma critical. So implementations of critical pragma will result of poor speed up. So can you suggest any other solution other than pragma and cloud that can be used to avoid critical pragma? So if let's say you have a critical of a scenario happen, how you're going to use, whether it's going to use only pragma and clauses, or maybe you can also use any others in kind of solution in terms of just using a critical pragma. That is under single master and critical. And after this, you're going to see uh, in terms of your open MP cluster. Classes, you're going to see you have a classes is an optional, whether you have it or not. So back to your first and the starting, you can see over here, pragma om, which is your pragma list. If you need to have your cluster, you can use it. Or maybe you just want to ignore also can, because it is a optional. Mana tadi? Okay, go back to the existing. Okay. It is an optional. So classes are used to, what is the use for your classes? Classes can be conditionals of parallelizations. Second is degree of concurrency, and then your data handling. You can use if needed only. If in the situation, if you have given with the situation, but there is no need for you to use the clusters, so you just ignore your clusters command. So you just ignore it. But if needed, depending on the situation, you need to have a full uh, command right up over here, like pragma om. Let's say you have a parallel for, and then what type of classes that you're going to use. Okay, go back to the exact slide. Where is it? Okay. So whether you can divide it into conditional parallelizations and degree of concurrency, and also your handling, data handling. Now there is similar to your pragma, same goes to your pragma. Your classes also have several lists that you can use, like your classes private, first private, last private, reductions, if, schedule, no wait. So you can find out what is all these classes are for. You can take a look and read it one by one, and maybe also you can try and apply it into your programming and see what is the difference between each other in terms of the output. Sometimes you can run a similar programming, but when you are using a different kind of classes also, you're going to get a different kind of output in terms of the grouping, in terms of your treats and so on. Is going to be slightly different. So there are several other programming which is we going to look and try it, and I'm going to assume it also. But your lab 3, I forgot. Last week I give to another section. I guess it is from our module 6. Later on, I will double check. Okay, so all the programming, your source code that available, and in terms of example, we're going to run it into our Ubuntu and we're going to run it together. So I hope that there is no one will be given the excuse maybe your Ubuntu suddenly corrupt next week, or maybe you cannot run it due to some others error or so on, because I guess you already done your lab 1, lab 2. So there is no excuse in the class if let's say we're going to run it together and I ask someone to show the answer. I hope that there is no some there is no student will be um, give me any excuse on that. So over here you can see we have open MP program. So under our open MP program, we can see we have several different kind of pragma om. Over here we are using a pragma om parallel. So you can see over here pragma om parallel, and we apply it into our programming, and then from here we want to compile and execute. So if let's say we having this kind of programming, what is going to be the output and so on. So next week we're going to do together and try it. So before the class, maybe you can try also write it, and maybe let me check. Yeah, maybe there is some error also. Please try to find it. Where it should be the error and how you're going to recorrect it. And over here, you have OpenMP code 2, which is you are using a parallel reductions, and you are using a num of threads, and yeah, only that. So you can see you're going to also do uh, the similar things, which is you're going to execute, and you need to find the error also inside of these codes. Only 2 program. Yeah, I think I'm going to put it as another lab. I forgot number of total lab. I guess 6 in our this semester. Yeah. I need to check back. Okay, now we're going to move, which is under our threads. How you're going to assign iterations to your thread. You're going to assign the iteration to your thread. So the schedule classes of your 4 directive deal with the assignment of iterations to threads. The general form of the schedule directive is schedule. So scheduling class and then parameter. There are 4 scheduling classes that you can use, which is static, dynamic, guided, and runtime. So after this, you're going to see all of these 4 scheduling classes and their uh, what is their descriptions and also tasks for each of these classes. So under static, the general form of static scheduling is schedule, static, and then you're going to have your shrunk size. This technique split the iteration into equal shrunk of size, which is shrunk size. Assignment to treat is done in a round robin functions. So you need to see several keywords under static. First is it's going to be equal size. Second is going to do the round robin fashion. And then you're going to have your dynamic. Under dynamic, it's going to be assign a partitioning shrunk when a treat become ideals. So this is the only keyword for your dynamic. So there is also similar, which is general form of your dynamic, which is schedule, dynamic, shrunk size. If let's say you have your shrunk size, it is not going to be specific. It defaults to a single iteration per shrunk. How many size shrunks that you're going to use and so on is not going to be specific. And third is guided. Under guided, let's say you were given a situation. You need to consider partitioning a loop of 100 iteration with a shrunk size of 20. It's already given you the size of shrunk and also your iterations of 100. This respond to 5 shrunks. If they are 3 treat will be get a shrunk each. The single remaining shrunks will be get 2. So altogether, you can calculate it. This assignment result in consider ideal mode for, okay, the ideal mode is a dynamic. The other first 3 is treat. The other first 3 treat. So your solution, you need to see first the shrunk size. So you're going to reducing the shrunk size as executions of the loop process. So in the class schedules, let's say this one is your guided. The size of the shrunk assigned to treat is exponentially reduced in the next round of shrunk to treat assignment. So this is under a guided. You can see a solution how you're going to solve in terms of the situation given. So this one is only one example. So lastly, you're going to have the run time. So for run time, let's say normally it's going to be used to a delay scheduling decisions until a runtime. If let's say we like to see the impact of various scheduling strategy to select the best one, let's say you need to find where is the best solution, where is the best numbers. So the scheduling can be set to the runtime. So normally you're going to use the variables of your schedule in term of runtime classes. So you can see also over here you can use the schedule instead of your static. Okay, this one is your static one. So there is only 4 of your scheduling classes that you can be grouping it: static, dynamic, guided, and also runtime. And under your synchronize across multiple for directive, this one is the last things that you need to know, which is it is oftenly is going to be desirable to have a sequence of your for, because you're going to have sometime in your programming they are too long in terms of your programming, right? Over here you have one for, and then there is another for, and then you have another for. So how, let's say you're going to execute it in terms of sequence, in terms of your programming, whether you need to justify it, which one is the first and which one is second, and so on. So of the four directives within your parallel construction that do not execute an implicit barrier at the end of the directive. Let's say this is all your task A, task B, task C. So all these four, you need to perform it parallelly. But how you going to define it in terms of sequence directive? OpenMP provide a cluster which is no wait. After this also you're going to learn more, which is wait, no wait. In terms of, let's say, if you have these four, if you apply a wait, so you need to wait for this task A to finish. Although you are using it as a parallel, you need to wait. But if there is no wait, means that you going to do it parallelly without you wait for others tasks to finish, which can be used for a directive to indicate the thread can be proceed for the next statement without waiting for other thread to complete for the loop execution. So this is the functions of your no wait. So this is all under your module 7, but later on you're going to see different others. So we're going to try to do a lab and try to run it in our Ubuntu together in our next class. So is there any question throughout our module 7? We have only another one module, last module, which is our module 8. Basically, if you check, I don't know whether it's already officially announced or not, but we going to be stick with our uh, final assessment for our final exam. We're not going to be have online final exam, but our final exam will be using final assessment term. So you are given 1 week to solve the problem, and then you need to upload the answer to the e-learning. After this, what you're going to have is you need to have another one programming test, and also you're going to have a project. So by next week, maybe I'm going to share the project assignment, and I don't want to set your programming test before we try do a lab together. So maybe I'm going to share the question first for project, and I think I'm going to give and assign you with a group. I don't want you to find your own group. It's going to be like maybe a sleeping partner inside that. You know your friend, okay, tolong ah buat, something like that. Maybe aku busy ni, kau buat dulu lah. Bila dah kawan-kawan tu, so macam susah sikit nak excuse. So I hope that if I assign you with a team member group, so it's going to be okay. But if let's say you have a problem with your team member, maybe your team member also did not cooperate with you, or maybe like in terms of sleeping partner, so you can always inform me. So maybe the one that's be a sleeping partner will do it alone. Last semester I guess 3 or 4 person in one group. So I need to see how about this time. Maybe similar numbers also, 3 or 4 in one group. What you need to do is, last time is like you need to do a research, a small research only. Uh, there is a several topic that will be give as a list. So you just need to pick which topic that you want to explain. You need to like write a report on that, and also in term of you're going to present it. So same goes to last semester. We will do all the presentation online. So there is no face to face, right? So any question? So if there is no more question, I hope that you can try to check whether you already scan your QR code attendant or not. And we're going to find again. We're going to try to find a solutions in all the examples in next class, in all the example given in the notes. And please make sure you see the lab 2, and your lab 2 need to be in term of PDF and also a video. Don't zip your file. Okay, so any other question? So if there is no question, I'm going to end up our class now. So thank you for your participant, and please make sure that you are in a safe mode. Thank you and bye bye.
Bye. Thank you, Doctor.
Okay, thank you.
Thank you,
Thank
Doctor.
you.
Uh,
Okay, bye bye.
Bye. Assalamualaikum.
Salam.